This is the second video on the distance formula, the 6-2C lesson. We're going to look at number 9. It says, find the distance between each pair of points. Leave your answer in simplest radical form. All right, so we have 2 points, A and B, and we're going to find a little bit of room here, maybe right here for A. We're going to write the ordered pair for A, which is right 6 and up 3. And then for B, we have left 3 and down 1. All right, so the distance formula, to recap, it was label our points x1, y1, x2, y2. Set up our formula. By the way, here's the formula again, even though it will be on the word wall. It's x2 minus x1 squared plus y2 minus y1 squared. Notice the minus signs in the parentheses and the plus sign in between. Alrighty. We have a lot of room to do this. We'll see if we can fit this in. All right, next, we're going to plug everything in it. It's negative 3 minus 6 squared plus negative 1 minus 3 squared. And we still have this big square root and a plus sign. Even though writing some of that stuff is annoying, it's important to do that so that you don't forget to do it and all your steps check out. All right, next, I'm not a fan of doing the sign change on the original problem, so I'm either going to type this in the calculator, do an additional step for a sign change, or maybe I know this is negative 9. It does need parentheses, and this is negative 4. Otherwise, this negative isn't going to go away. And this exponent 2 is a negative killer. It will cancel the negative. If I don't have my parentheses and I type this in the calculator to help do some number crunching, it's going to say it's negative 81, but this is positive 81, because this in module 5 was negative 9 times negative 9 plus, and this is negative 4 times negative 4, which is 16. And then we have square root of, we're going to add these up, 97. Well, 97 doesn't have many options. In fact, I think this might even be prime, so this is fully simplified. One other way we should point out that we could consider doing this is that we could draw in our triangle. Right? And we could Pythagorize this and count the legs and use Pythagorean theorem as well. We should also think about, in this problem, I started at point A, called it point 1, and went to point B. But you might look at this and say point B is actually kind of first on the graph. So we could think of this as going from our house to Degania Middle School, and then going from Degania Middle School to our house. The distance from each one of these is the same. Doesn't matter which way we're going. So technically, it doesn't matter if we call this point 1 or if we call this point 2. We're going to get the same answer, but I would just say be consistent. Maybe just stick with one way of doing it because it will improve your accuracy. But technically, it doesn't matter which one is point 1 and point 2. You just got to make sure all your 1's are together and all your 2's are together. We get the same answer. Because also remember that distance for this triangle, none of these lengths are going to be negative. So this is 4 units, and this is what? 1, 2, 3, 4, 5, 6, 7, 8, 9 units. And so these are not negatives, nor is this distance. Don't get that confused with slope, which had negative values, because slope determined the steepness and the direction. Okay. So 11 says, when finding the distance between 2 points, does it matter which ordered pair is first? The answer is no. And I just kind of touched on that. We're not going to explain this thoroughly. And we're on to the last thing, which is we're going to look at a triangle. It says use the distance formula and Pythagorean theorem to show that triangle ABC is right. I'm not going to graph this. We can let it cross that off if we want. We're going to find these distances. So this one I would say is the easy one, because you're going to pick one of these. And this one is medium or difficult. And this one is medium or difficult. So you're going to choose one of these. Okay. I don't care which one you choose. If you choose the easy one, then you're labeling your points. And you're writing out the work here and simplifying it all the way down. If for some reason you're inclined to do one of the medium or difficult ones, go for it. I'm going to show you the answer in just a second, but you're going to need to pause the video to fill that in. And you're welcome to copy down the answer, but please make sure you have the work for whichever one of these 3 problems you chose to do. You only need to choose one. Okay, so you hopefully tried one of these, or you're planning to go back and try it. And we're going to fill in our distances. So if you chose to do this one, you should have received square root of 117, which has a perfect square of a 9 in it. And so this is 9 times 13. So this answer should have been 3 root 13 if you tried this one. Again, I'm not showing the distance work. You're going to put that in. Now, if you didn't do this one, you're still going to copy that down because we need that. If you chose to do this one, you should have had square root of 52. And square root of 52 had a 4 and a 13 in it. And so this was 2 root 13. And lastly, if you chose to do this one, you should have received square root of 169, which actually is a perfect square. It's 13. Okay. In fact, we might want to add that to our word wall of perfect squares now that we've come across that one. Lastly, we are going to use Pythagorean theorem to show that this is a right triangle. And before I go on with that, or we're going to use the converse of the Pythagorean theorem, is I need to figure out which one of these is the biggest side. And it's going to be this one, because it might be difficult to determine when you look at the square roots. But prior to simplifying this, this was the largest square root unsimplified. Okay. Pythagorean theorem states a squared plus b squared equals c squared. And we're going to plug these in. So I'm going to have the first one be a. I'm going to have the second one be b. And I'm going to have the third one, like we said, BC. And the main reason we're doing this is because also this was tricky, and this is on the upcoming Monday quiz. So we're going to remember that we have to distribute or apply these exponents. And this was also the converse of the Pythagorean theorem that allowed us to test if something's a right triangle. This is 9 times 13. This is 4 times 13. And this is 13 times 13, which is 169. All right, 9 times 13 is 117. This is 52. And we are looking for a true statement, and that's what this is. It works out. So we now know it is a right triangle. All right, so today we looked at the distance formula, which was based on Pythagorean theorem. As you go to do the homework or the exit ticket today, I would recommend showing all the steps. If you don't want to do this step, you feel like you know the formula, that's fine, but I would suggest labeling your points, showing the whole formula with this massive square root, and then just carefully going through that and making sure that you still have the square root here. It actually doesn't cancel out. We add these up, we're just doing order of operations, and then we look to simplify the square root in the very last step. So we have it in simplest radical form.